Hi friends, in this video we see higher order differential equation type 2. Already I posted one video on type 1, so please refer that, then only you will know how to follow the procedure, because the finding the value of a complementary function is same for all the types, only particular integral will vary. So in order to understand how to find a complementary function, please refer my video on higher order differential equation type 1, then only you can follow this procedure. Let us start. Suppose if right hand side of the higher order differential equation f of x is equal to sin ax or cos ax format, then particular integral is given by 1 by pi of d sin ax or cos ax, in which we have to replace d squared in pi of d by minus a squared. Provided if you replace d squared by minus a squared and the answer is not 0, that is the particular integral. If the denominator, that is pi of d, replaced where d squared replaced by minus a squared becomes 0, then what we have to do is we have to multiply the answer by x and differentiate pi of d one time. That's what pi dash of d, and keep it sin ax or cos ax. If again after that what we have to do, again replace d squared by minus a squared in this denominator, provided pi dash of d not equal to 0. If pi dash of d equal to 0, then again multiply by x, differentiate second time, so it will become, the new pi will become x squared into 1 by pi double dash of d sin ax or cos ax. Like that it will go. When you solve the problem, you will understand how we are proceeding. Suppose instead of sin ax, if we are having sin ax plus b or cos ax b format also, then we have to follow the same procedure, right? So I hope you understand this. Otherwise, if I solve the problem, you will clearly understand everything. Let us solve this problem. Solve d cube plus 2d squared plus d into y is equal to sin x. So right hand side f of x is sin x. You see, left hand side is differential equation, right hand side is f of x. F of x equal to sin x. Here a is equal to 1, sin ax. So sin ax format, a is equal to 1. So it is type 2 integration, like that only, type 2 differential equation. So we came to the conclusion that is it is type 2. So total solution y is equal to cf plus pi. First we have to find cf. What we have to do? Replace d by m. So m cube plus 2m square plus 1, right? Uh, so right hand side f of x must be replaced by 0, right? We have to find the factor m into m squared plus 2m. Here d means m, sorry. So 1 is equal to 0. If you simplify, what you get is m is equal to 0, m is equal to minus 1, right? So what is complementary function for m is equal to 0? It is unique. So a e power x, so a e power 0 plus this is two equal roots. So it is ax plus b. So here already we have one constant a. So I write as bx plus c e power mx. M is minus, so e power minus x. So cf is a plus bx plus c e power minus x. This is what complementary function. If you don't know this procedure, please refer my video on differential equation type 1. Now we have to find a particular integral. Particular integral, the method of obtaining particular integral is different here. How we are going to find? So as I told, pi is equal to 1 by pi of d. Pi of d is given thing. So it is d cube plus 2d squared plus d into sin ax, sin x1. What we have to do? Replace d squared by minus a squared. A is 1, minus a squared is minus 1. So I replace this. So what I do? D squared is minus 1. So minus 1 into d. Plus 2 into d squared is minus 1 plus d. So what I get is minus d plus d cancel. So it will become minus 1 by 2 sin x. That's it. This is what our particular integral. So my solution is CF. What is our CF? CF is given here. A plus bx plus c e power minus x plus pi is minus 1 by 2 minus 1 by 2 sin x. That is our answer. Very simple problem. Right, next we go to another problem, different types of problem. Right, so solve b squared plus 1 into y is equal to sine squared x. Sine cos should be there, but it should be in the form of sine ax, no square cube and all. So we have to convert into different format. So first it is in the type 2 only, but little variation we will modify. So first we find CF. In order to find CF, we have to find auxiliary equation, replace d by m, and the right hand side should be equal to 0. This implies m is equal to plus or minus I. It is complex, so CF is equal to e power ax. A is a real part, so here a is equal to 0, imaginary part is 1, right? So a is a real part, a e power 0x, so it is simply a e power x, and b cos bx, b is 1, plus c cos bx, or c sin, right? C sin bx, so sin b is 1, right? If you don't know, please refer my video on how to find a particular integral. Sorry, C complementary function. So this is what complementary function, right? So sorry, this is general, please. A e power ax, general format is e power ax, so I write it again clearly. A cos x plus b sin x. This is what our answer. Because when you have a complex root, what is CF is equal to e power ax, a cos bx plus b sin bx, right? So a0, so e power 0 is 1, a cos b is 1, a cos x plus b sin x. So that is the correct answer, right? So a cos x plus b sin x. Now we have to find pi. If you want to find pi, right hand side should be in sin ax or cos ax format, not square, cube, and all should be coming. So let us see how to find. So pi is equal to, as usual, 1 by pi of d. Pi of d is d squared plus 1 sin squared x. This I modified as 1 by d squared plus 1. Now I write sin squared as 1 minus cos 2x divided by 2. Now it is cos ax format. That is very simple. So 1 by d squared plus 1, fine. So everywhere 1 by 2 is common. So I take 1 by 2 outside, right? So this is 1 by 2, 1 by d squared plus 1 into 1 minus 1 by d squared plus 1. I multiply 1 by d squared plus 1, right? I multiply with this, I multiply with this. Okay, now what will happen? So this is 1 by d, 1 by 2. I can write 1 by d squared plus 1 as e power 0x, e power ax format, right? It is type 1. 1 minus 1 by d squared plus 1 cos 2x. Right, in type 1 what we do? We replace d by 0. So what will happen? As per this is type 1 format. So type 1 format, this is type 2 format. So in type 1 what we do? We replace d by a. This is a. So this is 1 by 0 plus 1. Minus here we have to replace d squared by minus a squared. A is 2. So a squared is 4. So minus 4. So 1 by minus 4 plus 1 cos 2x. Like that we will do. So it will become 1 by 2, 1 minus, 1 plus 3 cos 2x. This is what our particular integral. Therefore, our solution is y is equal to CF. CF is a cos x plus b sin x plus 1 by 2 I bring inside 1 by 2 plus 1 by 6 cos 2x. This is what our particular integral. Fine. So a very simple problem. Okay. Next problem is, let us see, solve d squared plus 9 into y is equal to 11 cos cube x. As usual, cos is there, but it is in cube, so we have to convert into ax format. We will do later. Right? First, we find a complementary function. For that, we have to find the auxiliary equation. What we have to do? Replace d by m. So m squared plus 9. Right hand side, we have to make it as 0. This implies m is equal to plus or minus 3i. So it is a complex root. For complex root, we have to find AB. A is a real part is 0, imaginary part is 3. B is an imaginary part. Now, what is CF? E power ax, e power 0x, so 1. Then a cos bx, bx is 3 plus b sin bx is 3. So this is what complementary function. Now we have to find a particular integral. Particular integral we know. First pi is equal to 1 by pi of d. Pi of d is nothing but this square. D squared plus 9 is our pi of d into 11 cos cube x. So it must be converted into ax format. We know 11 is a constant, we take it outside. 11 1 by d squared plus 9 cos cube x I can write as cos 3x plus 3 cos x. Now you see this ax format. So hereafter the process is same. So what we have to do, 11 divided by 4. Right? That's 4. So this 4 I take it outside, cos cube x format. So it is, now we can bring this side. So 1 by d squared plus 9 cos 3x. This is type 2 format. Plus 1 by d squared plus 9 3 cos x. Right? Here a is equal to 3, here a is equal to 1. Now what we have to do? We have to replace 11 by 4, replace d squared by minus 3, say minus 9, with d squared by a squared. Okay, sorry. D squared by a squared, a is 3, a squared is 9, so minus a squared. Here replace d squared by minus a squared minus 1. So 11 by 4, 1 by minus 9 plus 9 cos 3x plus 1 by minus 1 plus 9 3 cos x. So what will happen? It is 11 by 4. Right? It is denominator is becoming 0. So I will tell you what I have to do when denominator becomes 0. This is 3 by 8 cos x. When denominator becomes 0, what I told, when denominator becomes 0, multiply the function by x and differentiate the denominator, so it will become d squared plus 9. You have to do, this is only making denominator 0, so multiply this function by x, differentiate the denominator with respect to d, 2d plus 9 becomes 0. When you differentiate d squared plus 9, it will become 2d, right, into cos 3x, right? So what will happen now? It is c 1 by 14, right? So this is x by 2 is this one. You see d is nothing but d by dx. 1 by d is differentiation, 1 by d is integration. So x by 2 I take it outside, it will become 1 by d cos 3x. That means we have to integrate the cos 3x. If you integrate the cos 3x, what will it become? Sin 3x by 3. So please remember, d by dx is capital D. D is equal to d by dx. So 1 by d, this 1 by d, 1 by d is nothing but integration. So integral of cos 3x, that is sin 3x plus 3. So this is 3 by 8 cos x. Now what happens? The answer is 11x by 24 sin 3x plus 3 by 8 cos x. That is what our particular integral. So complete solution y is equal to CF already we found a cos 3x plus b sin 3x. It is in top side plus pi 11 by 24 x sin 3x plus 3 by 8 cos x. Sorry, 3 into 11, so 33 by 24 cos x. This is our answer. I hope you understand all the problems. If you have any doubt, please ask me in comment section. I will clarify. Thank you.